All right, let's go ahead and continue on learning about this concept of stoichiometry, where we take the grams or the moles of a certain substance and convert it to moles or grams of another substance. So, for example, if we start with 50 grams of reactant, we can then calculate how many grams of a certain product will produce. And so what we've done so far is we started off with just going from moles to moles. All right, so we started off with that as very basic and straightforward. Then what we did is we added grams into it. So we went from grams of substance A to moles of substance A to moles of substance B. We also went from moles of A to moles of B to grams of B. And so all we're going to do now today is we're going to go from grams of substance A and we're going to go all the way to grams of B. And again, to do that, we've got to go to moles of A, then moles of B, and then grams of B. Now, just a quick reminder, we will always start over here. And we will always end over here. So it's really easy. You just have to look at this flow chart. You got to figure out, am I starting here or here? And am I finishing here or here? So let's go ahead and get going with that. If you take a look at this problem, the problem says how many grams of nickel metal. So what it's asking for grams of nickel metal are needed to completely react with 23.5 grams of oxygen gas. And so it gives us 23.5 grams of this. And so it's asking, how many grams of nickel metal. So it's giving us grams and it's asking for grams. So again, we're starting with the grams. We're starting with 23.5 grams. And what it's asking for, and this is grams of oxygen gas, and what it's asking for, well, how many grams of nickel? Okay, so here's our flow chart. We need to go from grams of oxygen gas to moles of oxygen gas. We then can go from moles of oxygen gas to moles of nickel, and then we can go from moles of nickel to grams of nickel. And so this is the flow chart that we're doing. All right, so let's go ahead and get going with that. So we are given, so step one is write what's given to you. We are given 23.5 grams of oxygen gas. Also, what I'm going to do is I'm actually going to color code this so we can really see what's going on. I'm going to make this purple. So we multiply by some fraction, and the units we start with go on the bottom. Again, this part is so easy. Just put the units you start with on the bottom. Now what we're going to do is, if you take a look, we're starting with grams of oxygen gas. So again, we're going grams of oxygen gas. Then we're going to go to moles of oxygen gas. Now something I want to point out is notice how this is also color coded. This all represents oxygen gas. This all represents nickel. And so we're going from grams of oxygen gas to moles of oxygen gas. Now, we don't necessarily, we don't want moles of oxygen gas. We want to go to grams of nickel. And so we do need to go another step here. And whatever's on the top on the previous fraction goes on the bottom on the next one. Again, it's very easy. This part's easy. You just put this here always. Whatever is on the top of the previous one goes on the bottom of the next one. And if you take a look, these units cancel out. And according to this flow chart, we now go from moles of A to moles of B. So we go from moles of oxygen gas to moles of nickel. And notice how when we go mole to mole, the substance changes. So we now have a new substance. We were dealing with oxygen gas before, but again, when we go mole to mole, we are changing the substance. All right, but again, we don't want moles of nickel. If we were to stop here, we would successfully convert to moles of nickel, but we don't want moles of nickel. We need to go one more step here, and we put moles of nickel on the bottom. And we're going to go moles of nickel. If you take a look at the flow chart here, we're going to go moles of nickel to grams of nickel. So we're going from moles to grams. And this is our setup here. And so what I want to point out here is notice how all of this here is oxygen gas. And then notice how this is nickel. Now, what's also really important is that you set up your units without putting in numbers, because if you can set your units up properly, then and you fill in your numbers afterwards, it's going to be very useful. It's going to eliminate a lot of mistakes that students make. And so now we can fill in our numbers, and this is the order in which I think you should do it. I think you should ask yourself, what always goes in front of moles? Okay, well, a 1 always goes in front of moles, except if it is a mole to mole fraction. If it is a mole over mole fraction, you do not put a 1. Instead, you put the coefficients in the balanced chemical equation. So what's the coefficient for oxygen gas? It's 3. Okay, what's the coefficient for nickel? It's 4. So again, a 1 always goes in front of moles, except for when it's mole to mole, we use the coefficients. Now what we do is we use the molar mass of the substance we're dealing with. And so here we're dealing with oxygen gas, and oxygen has a molar mass of 16, but there's 2 oxygens here, and so we multiply by 2. And I got this number here from the periodic table. So you look at oxygen and you get the molar mass from the periodic table. And so we end up with 32. Now if you look at nickel, if you look at the periodic table, nickel's molar mass is 58.69. And there it is. That's your setup there. And all you need to do is you need to take this number, you multiply it by the top numbers, and you divide it by the bottom ones. And when you do that, you end up getting 57.47 grams of nickel, because the units we're left with are grams of nickel. And we box it, smiley face. There we go. Okay, let's go ahead and do this next one here. This next one again is giving us, if you take a look, it's giving us grams of nickel this time. Okay, so grams of nickel, we're given 19.8 grams of nickel. And then it's asking for grams of nickel 3 oxide. So what's asking for here? It's asking for grams of this. So again, this is a gram to gram problem. So in this situation, again, it's going to be the same exact thing. It's a gram to gram problem, but it's giving us the grams, the 19.8 grams of nickel, and it's asking for grams of the nickel 3 oxide. And so again, we take our mass, we go to moles, grams. So step 1 is to write what's given to you. Again, this first step is always this. It's always the same. You just do this. We have our nickel, multiply by a fraction, and the units you start with go on the bottom. All right, so we're starting with grams of nickel, and if you take a look, we're going from grams of nickel to moles of nickel first. And what we're going to do is we're going to set up another fraction here. Grams of nickel cancel out. We put moles of nickel on the bottom here, because again, whatever's here goes here, and the whole idea is that that cancels out. And then we're going to go from moles of nickel to moles of the nickel oxide. And the moles of nickel oxide on the bottom, we're going to go to grams of the nickel oxide. So let's go ahead and take a look at this first, this setup here. We went from grams to moles, grams of nickels to moles of nickel. Then we went from moles of nickel to moles of the nickel oxide. And then we're going from moles of nickel oxide to grams of nickel oxide. And if you take a look here, it's essentially what we did here. So we're going all the way across. Now, something I want to point out is, if we were to stop here, in other words, if we were to not have this last fraction, we would actually successfully convert it to moles of the nickel oxide. But it's not asking for that, it's asking for the grams of the nickel oxide. That's why we go one step further. Now we can fill in the blanks here. A 1 always goes in front of moles, except when it's mole to mole. When it's mole to mole, you use the coefficients from the balanced chemical equation. The coefficient for the Ni is 4. The coefficient for the NiO3 is a 2. We then use the molar mass from the periodic table here. So we look at our periodic table for this, and this is 58.69. And then again, for this one, we use the molar mass as well, because again, we're going to grams. So grams is mass. We'll use the molar mass. And nickel, again, is 58.69, but we multiply it by 2 because there's 2 nickels there. Oxygen is 16, but we multiply it by 3 because there's 3 oxygens there. You then add them together, you get 165.38. And this is what you put right here. So again, you just use the molar mass right here. Then what you do is you type this in the calculator, you multiply the top, you divide by the bottom, and when you do that, you get 13.95 grams of Ni2O3. You box it, smiley face, and that's it. All right, we're just going to do one more. And if you notice, the equation up here is not balanced. There's 2 nickels here, or nitrogens. There's 1 nitrogen there, so we have to put a 2 here to fix the nitrogens. But when we put a 2 here, that gives us a total of 6 coppers, so we need to put a 6 there. And if there's nothing here, that means there is a 1. Okay, this is giving us grams of nitrogen gas. So 12.2 grams. And it's asking for grams of copper metal. Okay, so this problem is giving us grams of a reactant, and it's asking for us to calculate how many grams of another reactant we have, or we need. So let's go ahead and set this up. This one, I want you to think about it. So we have grams, 2 moles, and then this is where we go, when we go from mole to mole, that's where we change substance, grams. So this is kind of the flow chart that we're going to use there. And again, this is exactly what is from the flow chart, from this flow chart here. So I'm going to set this up pretty quickly to show you how quickly you can do this. So we have grams of nitrogen. Go from grams of nitrogen on the bottom here to cancel it out. And again, we're going to go to moles of nitrogen. And then we put moles of nitrogen on the bottom again to cancel it out. Now we go from moles of nitrogen to moles of copper. Okay, and then moles of copper on the bottom here to cancel out the moles. We go to grams of copper. A 1 always goes in front of moles, except for when it's a mole-to-mole conversion. We use the coefficients from the balanced chemical equation. Nitrogen has a coefficient of 1, copper has a coefficient of 6. We then use the molar masses here and here from the periodic table. So we look at the periodic table for those. This is going to be 28. And then copper has a molar mass of 63.546. And that's the setup. So I did set that up pretty quickly, but I just wanted to show you how it is possible to be efficient with these problems, and also to kind of show you how easy it is to pattern. Whatever's here goes here, whatever's here goes here, whatever's here goes here. Notice how it just instantly goes on the bottom on the next one. And so you just have to figure out, what is this flow chart? And really it's where are we starting on these and where are we going? So where are we starting? Where are we going? And that's all there is to it. We will practice this more in class, and we'll have a daily check-in class, and we'll really get this down. Hope you have a great day. Take care.